This is the solution to Chapter 11 video assignment 2. The question states, you have a sample that is either copper sulfate or copper sulfate pentahydrate. Use freezing point depression and explain in mathematical detail how you can tell the two compounds apart. Be sure to consider the Van 't Hoff factor. So, to be able to determine if you have copper sulfate or copper sulfate pentahydrate, I kind of just thought of a little bit of an experiment that you could do and the math behind it. So, first, copper sulfate, the empirical formula is this. Copper sulfate pentahydrate is the same thing, but it's just saturated with 5 molecules of water. And so, kind of the equation you can do is you can dissolve, I just said 10 grams of the solute, 10 grams of this, well, 10 grams of the unknown substance, right, into a solvent, say water, like 100 grams. Okay, so we'll dissolve 10 grams of the unknown solute into 100 grams of the solvent water, and then we will put it in some kind of liquid bath that's colder than like -5 degrees Celsius, or maybe in a cold, really cold room. Basically something that will make the fluid in the test tube here really cold. And then put a temperature probe in there, attached to something to measure the temperature. And essentially what we're doing is just stirring it and allowing this to freeze. And you can see when the temperature kind of steadies out, it'll be the cooling curve looks like this, right? This is cooling it down, and then when it's freezing, it'll have that same temperature. That's how cooling curves work. So yeah, if you set up an experiment, you dissolve, I just said 10 grams of the mystery solute into 100 grams of water, and then you can see at what temperature it freezes at. And now I'll talk about the math that will determine, based on the results of this little trial, what compound you have, or what species is here. So the equation for freezing point depression is delta T, freezing, the change in temperature, is equal to I, the Van 't Hoff factor, times the freezing point, the Kraus-Kappa constant, times the molality. Okay, so for copper sulfate, first I just found the molecular weight. So we have molecular weight of copper plus sulfur, sorry, I forgot the word, sulfur plus the 4 oxygen atoms there. So adding all those together, you get 159.616 grams per mole for the molecular mass of copper sulfate. Now for this 5 this 5 water molecules, this pentahydrate, you got 5 times the H2 here. This is the molecular weight of hydrogen times 2 plus the molecular weight of oxygen. So that gives you 90.075 grams per mole. Now summing those two together, for the total mass of this here, molecular mass, 2.49.691 grams per mole. So first we're going to find, using the math here, what temperature copper sulfate, 10 grams of copper sulfate and 100 grams of water would freeze at. So we got delta TF here is equal to the Van 't Hoff factor 2. So this is gonna dissociate into a copper ion and a sulfate ion when you dissolve it in water. Based on the nature of the molecule there, it's going to dissociate those 2 ions. So for Van 't Hoff factor, that's going to be 2, because essentially that'll double the number of moles of solute. Okay, times by the Kraus-Kappa constant for water is 1.86 degrees Celsius kilogram per mole. So that's where we get that. Multiplied by the molality of copper sulfate, right? We have the grams per mole of the solute, backwards. I did the math somewhere here. Oh, right here. I found out how many moles are in 10 grams. Using the molecular weight that we found there, 1 mole per 159.66 grams times the 10 grams of solute yields 0.062650361 moles. So that's how many moles of copper sulfate are in 10 grams. Okay, where are we? So we got the moles of copper sulfate divided by the 0.1 kilograms of solvent. Okay, times that across, we get 2.33 degrees Celsius for the change in freezing point. Now we're going to do the same thing for the other compound here. So we have the molecular weight, 1 mole per 249.691 grams times the 10 grams of this mystery solute, which in this case we're assuming is copper sulfate pentahydrate, yields 0.040049501 moles. Now, when this dissolves in water, similarly to the copper sulfate by itself, it will dissociate into those two ions, but this water that it's saturated with will actually come off as well. So kind of what we'll see happen is that it's almost like you'll be adding more solvent to the mix, right? So we can assume that, it'll be the same number of moles of copper sulfate, even when the water comes off, you'll still have that same number of moles of copper sulfate that we calculated. So, and it'll be the same number of moles times 5 of the water, because there's 5 water molecules on the one copper sulfate pentahydrate molecule. So when it comes off, it'll be 5 times the number of moles of that. So that's what we do here. We have the number of moles times 5 for the water. So that gives us 0.200247506 moles of H2O. Now, if we multiply that times the molecular weight of water, which here is at the 2H and the O, that gives us 3.6075 grams of H2O. So when we dissolve this solute in the water, it's going to add 3.6 grams to the solvent. Okay. Now, coming back to, we're going to just find the freezing point depression for the copper sulfate pentahydrate. We have the same the same Van Hoff factor of 2, as we talked about before. Same cryoscopic constant for water, and then we use the moles that we got of copper sulfate here, divided by the same mass of solvent, water, except I added the mass of water that's going to come off of the copper sulfate pentahydrate. So instead of just the 0.1 kilograms of water, we'll have 0.1036075 kilograms. So that'll change it a little bit as well. So multiplying that across, we get 1.44 degrees Celsius for delta T. Now we know that the normal freezing point of water is 0 degrees Celsius. So if we subtract off 2.33, subtract off 1.44, in our little experiment here, if we get around minus 2.33 degrees Celsius for the freezing point, then we can fairly confidently say that this mystery solute, this mystery substance is copper sulfate. If we get around minus 1.44 degrees Celsius, then we can reasonably confidently say that the substance we have is actually copper sulfate pentahydrate. Now, I recognize that these values are a little bit close in number, so if this isn't a super accurate measuring device, you could always just adjust the experiment to say 50 grams of water, right? Make the solvent less, so the molality is higher. If the molality is higher here, then that's obviously going to yield a bigger difference in the freezing point depressions. But the principle is the same, just this hypothetical experiment. This is what you're going to do, calculate it out, the freezing point depressions, and then whatever we get experimentally, we compare it to that, we can know what substance we have. So.